All right, whenever you're ready.
All right, hey guys, how's it going? My name is Mark Kickta. I'm a former Linux engineer with a managed application hosting company in Southfield, Michigan. Currently working as a security consultant with BioPoint. So, is everyone having a decent time already? Yeah. All right. So, today's talk we're called Popping the Penguin, and we're going to do a basic introduction to Linux persistence. Now, why this talk in particular? Basically, it's to provide direction. You know, when I gave this talk in Chicago, afterwards I had a question posed to me. Why didn't you talk about rootkits? Because we're not going to talk about rootkits at all in this. We're going to talk simply about bash commands and commands available on the Linux system already. And that's because if we truly want to be effective as information security personnel, we really need to understand the concepts that we're talking about. You know, we need to be able to understand these tools that we are using, how they work and why they work, before we go ahead and actually use them in the first place. So by the end of this talk, we should have a fully functioning basic remote shell that we can use in order to maintain our persistence onto the system. So in this talk, we're going to have two actors. We're going to talk about the dichotomy between the sysadmin and the hacker. Now the hacker, they're generally cool people. Their motivations depend mostly on their affiliation. So whether or not we have our famous APT1 or our script kiddie at home, their motivations are going to differ. And of course, they always wear a ski mask. So our sysadmins are a little easier to understand. They have three basic motivations. The first is patching. The second is hardening. And the last is uptime. These three concepts together are the concepts that every sysadmin focuses on. They want to make sure the system is secure. They want to make sure the system stays up. And they want to make sure that nobody can get into it. Okay, so we're a hacker right now. We've gotten into the system. We've used our favorite kernel exploit. We're sitting at a root shell. So why don't we just use the same exploit to maintain our access? Well, like we said before, a sysadmin's main job is patching, hardening, and uptime. And in the course of performing those three duties, you will lose that access eventually. May take a week, may take a month, may take a year, but you will lose that access. So how do we keep that access with minimal risk of being detected? We use a backdoor. They're easier to hide, and it's easier to evade some of the logging, which we'll talk about right now. So in Linux, all the logs, for the most part, are stored under a directory called /var/log. And in there, you're going to see a lot of logs, access logs, etc. Two of the main ones that we want to look at, though, are varlog messages and varlog secure. Varlog messages is the log that handles all the system-level messages. So anything from the kernel all the way up to bash logging if it's enabled. And I can guarantee you on a properly configured system, bash logging will be enabled. So you really want to watch out for that. And then we have varlog secure. Varlog secure is where it's going to handle all the user information. So any authentication. So let's say you SSH in, you get in and you steal someone's credentials through social engineering. That will be logged into varlog secure, which then they can then ask that person, well, hey, did you log in at this time? The person say no, and then they'll know that they've been compromised. So we also want to watch out for that. Anytime you switch a user, that will be in varlog secure. So let's say you do su- and then run that, and then somehow find that password. That will be logged. So we want to watch out for that. When we delete these logs and when we clean them out, we want to make sure that we're not deleting 4 hours worth of data. During an incident response at when I was a Linux engineer, we noticed that a box had been compromised because it was missing 4 hours worth of logs. And we noticed that one application checked in every 10 minutes and wrote to this log. So using that, we were able to provide compelling evidence to get a formal incident response that someone had actually compromised the system. So when we're going through and we open up this log in our text editor, we want to make sure that we're only deleting certain lines that are associated with that, with our events and with us. So we want to look at the trends going on, so that way we don't leave any traces that we were there. Now, in order to combat that as sysadmins, what we can do is we can use something called log shipping. What this is, there's two main programs in Linux, one called stunnel and one called rsyslog. They both provide somewhat of the same function, but what it does is it sends these logs to a centralized server in order so that in that way, if we do delete them, if there is a compromise, we can go through and we can say, hey, what happened in this time? We know that there are logs missing. what is missing. And then that will show compelling evidence again that there was an intrusion, and then again your persistence will be lost. Now, one way to leverage that centralized logging is to use something called event correlation using something called a SIEM, SIEM, which stands for Security Incident and Event Monitoring. I don't know if any of you guys caught EggDropX speaking yesterday, but he was talking about somewhat of the same thing, except his had a blender, which was way more cool. But what you can do with an SIEM, and this is something that if you're intruding, you really want to watch out for, or if you're a sysadmin, you really want to look into getting, is that you can do something called event correlation. So let's say that you have, because in varlog secure, it'll record every failed login attempt as well. So let's say we want to correlate 500 failed login attempts and with one successful login for that same user. That will generate an alert and say, hey, you might want to take a look at this. Somebody just failed to log in 500 times in 5 minutes and then suddenly got in. Somebody might have brute forced that password. So what can we do? Well, as hackers, what we can do is we can shut off the log shipping. We can shut off our syslog. We can shut off syslog-ng, stop that service, and prevent them from knowing that we were there. However, what we also want to look at is spoofing those logs. Because what you can do with an SIEM as an admin is you can actually set an event to be generated. Say I haven't received a log in 10, 15 minutes. Well, that's pretty suspicious because I receive one every 30 seconds from this box. So I want to generate an event and I want to generate an alert saying, hey, somebody might be on this box having stopped it. Or if not, I want to go in and actually restart that service because logging is pretty damn important. So let's assume that we don't have any, assume our admin doesn't know this. Let's assume that we successfully mitigated the risk of being detected through logs. So now we want to issue our first step in maintaining access, which is going to be the rogue user account. Now in Linux, for those of you who don't know, all of the information for an account, all the account info, passwords, usernames, etc., are stored in two places: /etc shadow and /etc password. Etc shadow is going to contain all the hash password, with a link back to the etc password file, which contains the username, UID, GID, and a bunch of other stuff. So how do we create it? Well, we're going to insert a line into etc password that looks something like this. This is an etc password entry. Now, to be honest, when I was first starting in Linux, this meant absolutely nothing to me. But it's actually quite organized. So you look right here, mkicta, that's going to be your username, followed by the UID and the GID, both being 0. Now a UID and GID of 0 is going to be the root account, which is the administrator, or it's more analogous to the system level user in Windows. This part right here is going to be a comment. So what does this user do? Is this the systems administrator? Is this the MySQL database user? Is this the postfix user? That's going to be the home directory, so you see we can make that root. And then we have the user shell, bash, which is born again shell. So we insert this into the middle of etc password with an appropriate comment, so that way if someone's doing a cursory investigation of an etc password file for any particular reason, they can look and say, well, hey, this looks legitimate, this looks like it belongs here. We insert this into etc password, and then we're going to run pw-conv-r/. And what that is going to do is that's going to generate us a etc shadow entry. So it's going to set us a random password into the etc shadow file. And then what you can do is you can also open up etc shadow, and you can take that line at the bottom that it's going to generate and move it up if you want to be a little more secure and have a little more guarantee that you're going to remain persistent on the system. And then all you have left to do is run passwd followed by your username and change the password. And now you have a root account. Great, so what does that do? Well, you see this 0 again, going back to the 0 and the root account? That 0 links to the user root. So when we su dash into mkicta, that's going to automatically toss us into the root user. Because the way Linux handles usernames and the way Linux handles user accounts is it handles it by UID. So that UID of 0 is going to link to root, and so we don't even have to have the username to root once we get in. We won't need to have that varlog secure issue. We can just get right in. So how do we mitigate? Well, there's about 3 different ways to do it, 3 main ways. How many of you in here are familiar with tripwire at all? Cool, a good number of you. So There's two different versions of Tripwire. There's the freeware community edition that was originally created, and then there's the enterprise version. If you're trying to save money, as most sysadmins don't usually have a large budget, you're probably not going to be able to get the enterprise version unless you're, multi-million, multi-billion-dollar company. The problem with the freeware version is that it only checks in once a day. So it'll generate a hash value for each file that you want to look at, but it'll only check in once a day. So if we do have a SIM, if we do want to correlate events with time, it's not really good for our purposes. So then we can move on to something, configuration management like Puppet. Any of you guys use Puppet in your job at all? Puppet Enterprise? Okay. So Puppet is a configuration management tool. You have a Puppet server, and then that will pull down a copy of the file that it should be. So let's say that a hacker introduces a line that says, like the one before, it will completely erase that and replace it with the last known good version of that file. Problem is that that doesn't really generate an event. It just replaces it silently and moves on. So our last option is something like an IDS system for host-based IDS system. And what we can do with that is that we can detect whenever some of these files have changed. So for example, OSSEC. I know Wolflight here, he's actually the one who turned me on to OSSEC in the first place. Very cool program. And what we can do is we can send those logs to an SIEM, and we can go through and we can look at it and we can say, hey, this is correlated with known hacker activity. Somebody really needs to take a look at this right now.
So a note on that, the comment that you made, a couple points. You talked about the fact that you could erase the logs and now changing the files. The advantage with OSSEC was the fact that the logs also get sent to a centralized server, so the fact that you're trying to erase the logs or change the logs on the local machine doesn't matter. There's a master copy on the server.
Exactly.
And again, you can watch the file system for any changes to the files that you want to monitor. So creating a new user account, while it might happen, gets notified pretty darn quick.
Exactly. By the way, I know
not
Wolflight
once in 24 hours. It gets noticed within like 30 seconds.
Right. Exactly. And that's the advantage with OSSEC. By the way, I know Wolflight from Detroit, and I forgot to mention at the beginning of the talk, if you guys have any comments or questions, feel free to interrupt me at any time. I like to think of this more as a discussion than a lecture, because lectures aren't any fun. I hated them in college. But he's absolutely right. If you can cut that time of detection down from 24 hours to 30 seconds, as a sysadmin, you'll have a much better time. But as a hacker, you also want to look out for that. So let's assume that mitigation never happened. Let's assume that, like myself, I didn't know about OSSEC when I was working as a sysadmin. Let's assume that you just have a regular system. So now we have our user account and our logs taken care of. How do we make sure that we can get in to use that user? Let's say that SSH isn't available. Let's say that there's a whole host of other reasons. It's behind a firewall. It's behind a load balancer. We can use something called Netcat. Now, Netcat is a fantastic tool. It describes itself as the networking Swiss Army knife. And it can do everything from opening listening ports, connecting to open ports, scanning, banner grabbing, tunneling, and a whole other host of just awesome features. We're going to pay attention to the first two, though, connecting to open ports and opening listening ports. So there are two main ways to open up a persistent connection, a forward and a reverse. The first way with forward, we would do two things. One, we would run this on the pop box. Now, there are two flags in there, -L and -V. If you notice the -V is in parentheses because it's optional. The -L says, I'm going to open a listening port, so fairly simple. And the -V just adds verbosity, so if I want to actually see what's going on. The 4242 is going to be the port we open. On some versions of Netcat, you're going to need to do a -P, but you can just run man nc or just nc-h, and that'll tell you the syntax for your version of Netcat. Then to connect back, we just do nc followed by the popped IP and the port, and we now have our tunnel open. That's great. So what happens if it's behind a firewall? Let's say port 4242 or any other port is blocked. We can't just stop a service and use the port that's open, because that's just going to alert the sysadmin right away. So what we want to do is we want to do something called a reverse connection. So the host, the pop box, is going to connect back to us. So we see we're going to run this on our machine. On the hacker's machine, we're going to run Netcat, and then the box is going to run Netcat back to you and open that tunnel from its end. It's going to be the initializer. So you can see the flow is almost exactly the same except for which one uses which. So in a forward connection, you're going to use a high-level port, 50,000, 10,000, something like that, to connect to port 4242 on this side. But if there's a firewall, most places don't do egress filtering. So what we can use a high-level port on this side, and then connect to port 4242 on this side, where we control what firewall and what comes through. So what's the point of this? Well, this will bypass, reverse connections bypass, as we said, inbound firewall, egress filtering. Does not bypass egress filtering, but it does bypass inbound firewall rules. It'll help with load balance environments. So let's say you have 10 hosts behind one single F5, and you don't know which host you're in. Well, if that host is connecting back out, then you have persistent access to that host. Because if you hit that one IP and it goes to 10 private ones, there's no guarantee that it's going to be load balanced to that same host again. So what's the point? Oh, right. So how do we get this host to connect back to us? Because, if we're on the host running NC to connect back to us, there's really no point in actually doing this in the first place. So the first method that we have are daemons. What you would run would be nc-l 4242, then an ampersand, for example, which would allow you to run as a daemon in the background. Doesn't work too well. Daemons die, processes die, boxes get rebooted. Not really great for our purposes in terms of persistence. So we have a better method, Crontab. How many of you are familiar with Crontab in Linux? Awesome. I know you are.
Okay.
So there's two crontabs in the system. There's etc crontab, which is the system-wide crontab, and then there's var spool crontabs, and then followed by a username. And that's going to be the user-specific ones. And I'm assuming most of you who use crontab on Linux use crontab-e to edit and crontab-l to list. Well, that's listing this one right here. etc crontab, you actually have to go looking through. You have to go in and specifically look at that crontab in order to see if anything's been added. Because crontab-l will just show you your user crontab. So we want to use this first one up here in order to add this entry. So for those of you who aren't familiar with crontab, we have a handy little chart here for the syntax of cron. Pretty simple: minute, hour, day of the month, and then day of the week, followed by the command. So what this will do is this will run at 0200 on the 12th of every month, provided it is a Saturday or a Sunday, and it'll reboot. Absolutely useless command. Absolutely useless entry. But it just demonstrates the point in the syntax of how this actually works. So what's the point? We now have our connection. We can now send text back and forth. What do? Well, for starters, we can demoralize admins. Admins are very susceptible to trolling, and we can make them cry. Hopefully, if they cry enough, they won't actually be able to do their job well. Or, and crying admins are actually, not necessarily what we want to do. So there's three things that we can do. We can do egress filtering, total egress lockdown, and configuration control on the cron tab to prevent this. Or, now let's assume that there is no egress filtering. Let's assume that there is no egress lockdown. And let's assume there's no configuration control, because let's be honest, on most boxes, they want to do it for a budget. You want your web server to run on a budget, because it's not going to be the bulk of your business. It's depending on what you do. So what we can do is we can use something called I/O redirection to make this text flow actually useful for our purposes. Now we're going to take a little break here from the code, and we're going to go over how this actually works in Linux. Because with Bash, the born-again shell, which is what we use to interact with the system in Linux, uses flow programming primarily versus object-oriented programming. How many object-oriented programmers do we have in here? 1, 2, quite a bit. Now how many flow programmers do we have? 3, 4, 5. Significantly less. So, flow programming isn't that widely used anymore. But it's very cool when we combine the two together. So in the end of this, what we're going to do is we're going to combine flow and object-oriented programming together to make a really cool shell. So this is the first of our flow-based symbols that we use in order to change how the programming works. What this is going to do is it's going to take standard out on the left, over here, and then it's going to redirect it into a file over here. Pretty simple. This is going to take standard error on the left and redirect it to a file on the right. So 2 is going to be your designation for standard error. This is going to take both standard error and standard out and send it to a file on the right. Again, pretty simple stuff. This is actually used quite a bit with programming because if you're doing some things for administration tasks, you really don't care about the output, so you just send it into dev null and just absolutely ignore it. Now this is probably one of the most used flow programming based symbols that Linux has to offer. I know those of you who do flow programming will probably recognize this as the pipe. And what this will do is it'll take standard out on the left and pump it into standard in on the right. So what that allows you to do is take the output of one command and use it as the input for another one. So, and I apologize to anyone who actually uses Linux. This is going to be a bad example, but it'll demonstrate the point. Let's say you want to list every file in a directory under a specific directory. So you can do ls and then pipe that into ls. Really bad example because you could use find. A whole lot of things you can do. You can use a flag in ls, but it demonstrates the point of using this pipe. This redirects standard input, so it'll use any file over here and use it as the standard input for a file on the left. This is what we use to identify our files. So exec opens a file. The 5 right here, that's going to assign a file identifier 5 so that we can use a couple more advanced I/O redirection techniques on this file. Somewhat like this. So this will redirect standard output into the file with an identifier of 5. Then the last thing that we use quite a bit in Linux are FIFO pipes. Now what this will do is this will make a FIFO pipe called awesome. FIFO stands for first in, first out. It's a really cool feature of Linux, of bash. And basically what it is it's a queue. Whatever goes in first is the first thing to come out. Just like if you're at Cedar Point, if you're in first in line, you get to be the first on the roller coaster. Yay you. So here's our first command. You can see right up here, we're doing make FIFO. And HDA is going to be a generic device that we can make in dev HDA. It's not going to stand any scrutinization. There'll be a little P next to it if you do a long list in Linux. But it'll kind of fly under the radar a little bit. And then you can see what we have here. We have our actual connection command. So what we're doing is we're connecting using to our listening port. That's going to the cloud. Take a drink later. And then that's going to hit this netcat. So this command right here. That's going to get processed by bin bash right here. And that's going to get sent to the FIFO pipe. And that FIFO pipe gets redirected back through netcat. So you see we have this being replaced. Since this is a file, a FIFO pipe is a file, we can use our I/O redirection to send that back through the pipe. So any output that we get from running the command that's sent through here gets sent back to you. So that's our very basic bash shell. We're almost done. There's a second way to do this, because there should be multiple ways to do everything. This is going to be using a command compiled into bash called dev tcp. Now what dev tcp does is it calls the cconnect command to connect over any port on any given IP address if it's allowed. The best way to think about dev tcp is that it's a FIFO pipe but across a network. So it's a network-based FIFO pipe. So our make FIFO and our netcat, we're combining it together in something called dev tcp. I prefer this way because it's a little more robust and it's just cooler, to be honest. Also, it's very useful if, let's say, the admin has removed netcat or it's just not available on your system. So here's the command. It's a little more complicated than the other one, but we'll go through it. This can basically be broken up into 2 parts, initialization and execution. So for our initiation part, we have exec. Exec opens a file. Here's our next part, exec dev tcp IP port. This opens a connection as a file, as a FIFO pipe essentially across the network on an IP and port. And then all this is doing is assigning that file, that FIFO pipe, that network FIFO pipe, an identifier of 5, so that we can use redirection on it. Execution part. Cat will take any file and it will print that to standard output. So what we're doing here is we're directing the file with an ID of 5, so our FIFO pipe, anything coming through that pipe, we're going to send it to standard out. This is your basic while loop. While read line, so while anything is being read, we're going to assign it to the variable line. We're going to execute line, and we're going to keep doing that until we reach an end of file. We're going to redirect standard error back through this networked FIFO pipe. We're going to redirect standard out back through this networked FIFO pipe. And so what we have is we have a line that will cat out a file with an ID of 5, redirect standard out to standard in of the while loop, read in the commands from line by line until attempting to execute them, and redirecting the output and error messages back through the pipe to your machine. Pretty cool stuff. So this is what it looks like. So if you remember, here's our netcat command, our netcat flow. It goes through and redirects back around. We're just adding one little part into it. Is that we're adding this little while loop that allows this connection to remain open for as long as we want. So it sends it back through the pipe, but then you can see the process actually goes back to the while loop, waiting for more input. All right. We are almost done, actually. A little ahead of schedule, too, so. Now, let's say that somebody has actually put out or deployed an IDS and IPS. I mean, I'm sure most of you can see the problem with actual clear text commands going across the network. If there's anything that's suspicious, that's going to set off red flags among anything else. Because there's no time when you should be interacting legitimately with the system without encryption going on, whether it be SSH, RDP in Windows, anything. I mean, you shouldn't even be telnetting, to be honest, but I mean, I know people do it. So how do we solve this issue? How do we get around having our commands go through in clear text? What's up? Heard a question? Oh, okay. So we're going to use something called base 64. So base 64, if you don't know, it's just like base 8, base 10, base 16. It just has 64 characters in its alphabet.
Why don't you
So,
use CryptCat?
What's up?
Why don't you use CryptCat?
CryptCat? I actually, well, first of all, since it's a basic talk, I was just going with base 64. But I was building up, I'll just spoil the ending right now, to AES pipe. Honestly, I had never heard of CryptCat before. I mean, is that a Linux-based command?
No, it's just an encrypted version of Netcat.
Oh, really?
Yeah, just does SSL.
Okay. Well, actually, one other thing that I forgot to cover at the beginning. One of the things that I wanted to do was to do this without using any local certificates, so without having to upload anything to the server. It allows us to have the minimal impact on it. I mean, CryptCat is absolutely, and using SSL is absolutely key to having a good rootkit. To having a good intermediate rootkit, you want to have some sort of actual encryption. The problem with AES pipe is that it only works on objects, so like zip files, tar files, etc. So if you were actually making a rootkit, CryptCat would be a perfect example. But for our purposes of understanding the actual basis of how this works, we don't want to have to actually upload anything because we're looking at minimal system impact. It's a great point though, and I'll probably incorporate that into the next version of this talk. Thank you. Actually, come on up afterwards and
Use
talk to us about it.
OpenSSL.
What's that?
Use OpenSSL.
OpenSSL?
It's always there, usually.
Yeah, I mean, usually it is, correct. So to create our basic encoded shell, we're going to just add a couple extra lines, a couple extra commands, base 64-D and base 64. So what's going to happen is that it's going to echo the command, the encoded command that you send through it, it's base 64. It's going to echo that into base 64-D, run the command, and then re-encode that and send it back to you, where you can then decode it. So this is going to be our basic encoded shell. So run a quick video for you. I was going to do a demo. I was told not to tempt the demo gods, and they're right. I am nowhere near this good of a typist. Being able to cut video is awesome. Just saying. So you can see here, you can. Let's see. Can I change the resolution on this, or is that going to mess up your?
You could try it. It might kill the slide deck though on here.
Oh, all right. You know what?
I mean, you could try and dump it down, but
Suggestion is for the next time you do the talk, is change this so that your shell background is white and your text is black, and it will pop on the screen.
I had orange originally, 'cause that's what I usually use, and I realized that nobody could see that. I thought this would be a little better. Fortunately not. So I'll just talk it out loud. So you can see here we have our Netcat listening port. If you can't, apologies. And using our verbosity. Over here, I know no one can see it, but this is our pop box, and this is my FreeNAS box at home that I was using as a test subject. So we're not just limited to Linux. This also can work on Unix systems, anything running bash shell. FreeNAS does not run bash by default, but it is installed by default. That allows us to have this process actually work. You can see we're opening our dev TCP file. Actually, most of you probably can't see. You see, we opened our connection successfully. And so now we're actually going to run the encoded version of our remote shell. We're echoing the line into base64. We're decoding, running the command, re-encoding, and then sending that back through. As I said, not a very good typist. Unfortunately, Netcat-L does not like having its input and output redirected at the same time. Tried it with a bunch of different FIFO pipes. So as it stands right now, barring, I actually have a Python script running to actually run the client at home. You'd probably have to use a Python script, but for our purposes, doing it manually demonstrates exactly what we're talking about. So you can see the response that we got that was base64 encoded back from the pop box, from our FreeNAS server, Unix box. Then we echo that into a decode command. We can redirect that into a file, and then we can list the contents of that file. As you see, we have our FreeNAS followed by the list of our directory. So this can be pretty powerful if used in the correct ways. Obviously, you don't want to use just this. You want to combine this with other object-oriented options like Python, like CryptCat, like OpenSSL. And you can combine all these different ways into making a very potent, very transferable shell. Oops. Actually, come on. Oops. Okay. So these are the two operating systems we used. I connected from Fedora to a FreeNAS box and was able to successfully have a persistent connection through that using the tools that we described in here. So to wrap it all up, if you're a sysadmin, there's a couple things that you want to do, and it basically boils down to this. Know what's going on in your environment, monitor your flows, monitor your logs, monitor your events. Depending on how paranoid you are, and if you're a good sysadmin, you should be incredibly paranoid. You should do egress filtering. Or if you're like my friend back in Detroit, Wolfgang Gorlick, you can just go ahead and do total egress lockdown. And I was actually having a pretty good talk with him about this before BSides, in that it's a completely session-based firewall. Unless you have an open, legitimate session to that port 80, nothing goes in, nothing goes out. Like I said, he's incredibly paranoid. So this is me, security consultant, former Linux engineer, play way too many games. Member of MySec, and you can get me on Twitter. Here are the references that I used. Does anyone have any questions? If not, we can go ahead and end early today. But yeah, go for it.
So I've seen this done in Perl.
Mm-hmm.
Completely, everything done in Perl. If you use Netcat, Netcat will show up in the profit and list processes. So it's
Absolutely.
stands out while you're in Netcat on the system. If you're doing this in Perl, it's very, you can just route through here. Perl script is running, and that will be fine. Most of the time, you just look over. Other thing is that that was being done to 450 gig.
things that that I like to do with this and the command in general was that I don't really like Netcat. You know, I mean, I showed it as an example, but dev TCP, you toss it into a script, call it MySQL, call it whatever you like. You can kind of obfuscate what it looks like. If you really want to, you can $0 in bash will actually allow you to change what the running process is. So if you do have a Perl script, you can go ahead and you can change whatever you like. You know, you can change, or in terms of what it shows in PS, AUX-EF, whatever your chosen poison is. That's an excellent point, too, that he made, was that Perl is a great language. Python it also is another great language in order to do this kind of stuff. Bash just shows you the basic structure of how it works. It's not going to be great if you want to do persistence in the field, but you can apply the concepts from Bash and use that in Perl and in Python. Thank you.
So now that now that I went back and thought about your talk a couple times, I wanted to bring up another thing because I really want. When you do talk in Chicago, I'm like, besides Detroit, I'm going to hit him with an IDS solution he hasn't seen before that can stop some of his attacks. Because you weren't familiar with host-based IDS at the time.
That was awesome.
So with regard to host-based IDS, I mentioned earlier, and you mentioned that it can watch the file system.
Yes.
It can also watch activity and things like open ports. So you want to open a port, a non-standard port, fine. We're going to be alerted on that right away. Again, not 24 hours later, but you can set your alert tuning to whatever you want. 30 seconds, 5 minutes, whatever you need it to be to make yourself more aware as a systems administrator. But also, I'm a firm believer as a systems administrator in whitelisting. So I don't care that you try to do something with an IP or a random port. If your IP is not allowed to talk to my devices, it doesn't happen.
Absolutely.
So whitelisting is another great mitigation defense for systems administrators.
True. But I mean, let's, in terms of, like, let's say you have a web server, something going across port 80, you've got that, it's kind of hard to whitelist that.
But that's where you watch for, through your logs, you use OSEC to watch for activity that looks suspicious.
Right. Then you combine that with the
And
SIM, and then
you have to be a smart systems administrator and know what shouldn't be there. So
absolutely. And you combine that with the SIM, and you've got a pretty comprehensive solution.
if you've got base 64 traffic going out of port 80, you probably have a problem.
Right. And to be fair, that base 64 will probably only stop snort or some really basic IDS. If you've got a Cisco ASA, if you've got anything fairly advanced, you want to use something like CryptCat, like OpenSSL, in order to prevent that from being decoded on the fly. Yes?
Another one called the DNS cat for tunneling over DNS.
Very good call. I did not include that in the talk, but that is an excellent, absolutely excellent idea.
You can resolve a name, you can get out.
Yep, absolutely. Anyone else? All right, great. Thanks, guys.
I wasn't going to talk. Thank you.
Thanks, man. Hey, not a problem, man. Give credit where credit's due.